Welcome to our demonstration of standing waves. We're going to show a standing wave, and we'll just reset and start it. You can see now the wave is being generated from the left. It's moving through the medium, and of course you start with a wave crest, then you have a wave trough here. And we get a series of crests and troughs, and they're heading toward a fixed point. Now this is a fixed end. In other words, the end is likely more dense than the medium, and the wave will reflect upside down. Now when we show this wave reflecting upside down, we'll see that it reflects upside down, and we'll see that it's coming back in blue. And you can see now the red waves are still moving to the right, the incident waves. The reflected waves, however, are bouncing back upside down. Now when the incident wave is interfered with by the reflected wave, certain things happen. When we're at this point, we have a wave crest from the incident wave interfering with a wave trough from the reflected wave. When a crest meets a trough, the amplitudes add as vectors, and of course the sum of a positive and a negative is going to be equal to 0. And what we'll get, the resulting standing wave, will be a very small, or in fact it should be a 0 amplitude, as a wave crest meets a wave trough. And we'll just try to stop that right at the right point. There we go. A wave crest here is meeting a wave trough, and the resultant displacement of the medium, just for an instant, is 0. Then, of course, as we continue, we will get a wave crest meeting a wave trough, or sorry, a wave crest from one meeting a wave crest from the other, and these two wave crests, the amplitude actually adds as vectors, and so we get a positive and a positive at the top here. So we get a large antinode, and of course we get a negative and a negative adding together, and we get a very large negative. So we get a series of nodes and antinodes, or maxima and minima. There's a minimum right there, and of course this continues as the two waves interfere with each other. Now you'll notice this is from a fixed end, and therefore of course the wave is reflecting upside down. However, there's an antinode here at the top, and then there's another antinode here at the bottom. Antinodes in a standing wave are only half a wavelength apart. And same thing with the nodes. The nodes are only half a wavelength apart. Here's a node right here, and here's another node. Now of course you can see that from the top of this blue to the bottom and then to the top, that represents, this distance here represents a complete wavelength. However, you'll notice that the nodes are only half a wavelength apart, and as you'll see here, the antinodes are also only half a wavelength apart. Here's a wavelength from here to here, but of course there's an antinode and antinode at the bottom. Antinodes and nodes on a standing wave are only half a wavelength apart. And if we change this from a fixed end to a free end, you'll see that the reflected wave will not be upside down, but will be right side up. We'll just pause this for a sec. And now that the pulse has reached the free end, we'll now resume, and you'll notice that the reflected wave is right side up. All right, but you'll notice that we still have a series of, there's two antinodes, and there are two nodes, oh, missed it, antinode, and then a node right there, pretty close, and of course you get a series of nodes and antinodes. The nodes are still half a wavelength apart, the antinodes are still half a wavelength apart, and of course notice that the only difference between a fixed end and a free end is that from a fixed end the reflections are inverted, from a free end the reflections are right side up.